The leave plan of room specialists has tracked down that using our new 10 billion toy, it will be a very long time before that endeavor transforms into a reality. If it goes as arranged, the journey to Proxima B will require close to 20 years, so sensibly, it will be an extremely drawn-out period of time before we can avow, on the off chance that there is for sure life on that planet. The well-established request of whether we are really alone in this universe proceeds. The James Webb Telescope has discovered some startlingly humanesque things far away from Earth that lead us closer to the reaction. Our journey for life beyond us has been wild throughout every human development, so much that we have a considerable number of media composing and speculations in regards to this matter. Our wonder concerning our place and hopelessness in the universe has been predictable, like it is permeated inside us to continually search for a companion, no matter how outcast-like we might be. We might be getting progressively close to the reactions we truly need. How, anyway, are they actually the reactions we are looking for, or are they considerably more startling? Oblige us as we research the latest disclosures in the domains of universes and planets on the excursion to find something we most likely won't be prepared to notice. Lights quite far off. Analysts have found what could be the most significant exposure in history back in 2021 when the James Webb Space Telescope was scheduled to ship off. An extremely intriguing hypothetical request was raised about the limit of our development. The request was whether, later on, our telescopes could distinguish fake light on another planet, for example Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was acknowledged to be perfectly locked with an incredibly tough day side and night side, like our moon. A hypothetical inventive progress on Proxima B could move force and power from the day side to the night side using photovoltaic cells that produce power from starlight. Hence, in a paper with Manas V. Lingam as one of the examiners, it was shown that the large incorporation of the dayside sunlight-based chargers could be recognized with future telescopes. Since JWST was further developed, it would allow us to grow our quest for fake lights to valid exoplanets like Proxima B. Now, the way that the James Webb Space Telescope makes it possible in 2024 did exactly that using its higher responsiveness and more noticeable range of capacities. The JWST might have found the lights we were searching for and possibly hurled us into one more enormous surge of human headway. All in all, permit us to hop into the universe of planets and exoplanets to sort out how this was for sure even possible. James Webb's mission researches Proxima B's mysteries. Since the dawn of time, individuals have considered the possibility of the universe, what we are, where we come from, and where we go. These are typical yet very inconvenient inquiries that mankind has endeavored to reply since we procured consciousness. Now, in the time of exceptional mechanical progress, one thinks about whether we are any closer to answering these requests. If you were to ask an intellectual, he could say we are still at level 0 of understanding ourselves in the universe. Anyway, ask a cosmologist the very same thing and watch him skip all over in enthusiasm as he races to tell you the latest discoveries individuals have made about the universe using their sharp instruments. These gadgets, though not given a great deal of thought to by the common public, are clearly an indication of human headway itself. We presently have the world readily available, and the time has come we push ahead and get the universe readily available too. One such strategy for doing that has been contemplated by analysts and space specialists through the development. We prepare a specific arrangement of that advancement is, as of now, responsible for the new discovery of what might be light on a substitute planet light years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation imagined out of the legacies of human missions into space to answer a couple of anytime-present requests. Are we alone? Who's out there? Where do we start and where do we end? This infrared space science gadget has recently begun tending to these requests, notwithstanding the way that, to some degree, first you could get yourself asking, what is Proxima B? Proxima Centauri B or just Proxima B is here, and they're insinuated as Alpha Centauri SE. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could dumbfound you anyway, don't pressure, as this text will curb all your consuming requests. Super-Earths are a class of planets that are more tremendous than Earth, yet lighter than ice Goliaths like Neptune and Uranus. They are truly one of a kind. They can be included gas, rock, or even a mix of both, and their sizes can vary from 2 times the size of Earth to multiple times its mass. They really put the really in super-Earth. Concerning Proxima B, it is a super-Earth and an exoplanet, meaning that a planet crosses outside the close by planetary gathering. Without a doubt, the first possible evidence of an exoplanet was considered to be as early as 1917. In spite of the way that it figured out how to stir up little interest and affirmation, at any rate, in 1992, the first affirmed discovery happened, which left scientists perplexed. Another exoplanet, first recognized in 1988, was avowed in 2003. As of April 1, 2024, there are 5,653 affirmed exoplanets in 4,161 planetary systems. Out of these, 896 frameworks have more than one planet. These stupendous discoveries are orbiting an M-type star. To get a handle on the M-type star, you want to get a handle on the red dwarf. A red dwarf is the smallest kind of star in the main sequence, subsequently the name. In the connecting locale of the Sun, red dwarfs are by far the most generally perceived sort of star to be found in the Milky Way. They have incredibly low iridescence, and since iridescence is one of our principal devices for planet identification, what's more, various kinds of deductions, red dwarfs are not unreasonably easy to notice. The unobtrusive stars have variable definitions and names, depending upon their temperatures and sizes. For example, M smaller people or M-type sequence stars yield a maximum temperature of 30,000 K, along these lines getting their name. What's more, credits getting back to Proxima B, its mass is known to be practically identical to 1.07 Earths. Peculiarly, it simply takes 11.2 days to complete one circle of its star, stood out from our 365.25 days. You can gauge the size of the star Proxima B is circumnavigating brilliantly under the estimation of the entire electromagnetic reach. The star has a complete radiance of, figuratively speaking, around 1.6% that of the Sun. In addition, in the perceptible light reach, its radiance seems to dull impressively more. As it appears fainter, it only illuminates 5 to 6% of the Sun's sparkle in the observable light reach, releasing an on a very basic level lesser proportion of light energy. Stood out from the Sun, over 85% of its released energy is as infrared radiation, orbiting about 0.045 to 0.056 solar masses from its star. Proxima B's discovery was proclaimed way back in 2016. You might consider the reason why Proxima, along with a large number of stars, planets, and vast systems, is of such interest. Well, there are several reasons that add to the unmistakable interest space specialists have in this spot. Most importantly, Proxima B is the closest known star to our Sun. What's more, by definition, 4.2 light-years is a significant number to us Earthlings. In the well-conceived plan of the universe, it is a straightforward blip. In this way, why Proxima B, our closest realized star, is high up on the priority list right now, it is in like manner a piece of the triple star structure called Alpha Centauri. Besides, notwithstanding the way that Proxima's glow is very low, the real structure appears as conceivably one of the most brilliant magnificent bodies in the night sky, in a manner of speaking, behind two others called Sirius and Canopus. At any rate, the most charming thing about Proxima Centauri B is that it might actually be decent, since it falls under the livable zone. The potential results involving the star are wearisome, and as such, space specialists have taken on the mission to examine the profundities and restrictions of the ability of the star. That is where the James Webb Space Telescope comes in. The 4 imperative targets of the JWST are to search for light from the primary stars and universes that shaped in the universe after the Big Bang, concentrate on world plan and headway, handle star and planet formation, and concentrate on planetary structures and the beginning marks of life. As the JWST continues with its examination of the said exoplanet, we get progressively close to the completing of these missions, from looking for exoplanets to searching for pariah life. So what exactly is said, one could ask? Considering that individuals have perpetually been a curious species, hitting and bumping into, in an exacting sense, each possible thing that moves, furthermore, doesn't move, it makes sense that a mission like SETI came into existence on such a huge degree. Imagine that God has facilitated a stupendous, huge endeavor, anyway with a twist. All things considered, of gold, we are endowed with being on the post for flags, even more expressly electromagnetic mumbles from civilizations past whatever we might at any point envision. SETI, short for the hunt for extraterrestrial intelligence, is like the world's most high-stakes round of find the stowaway, with our planet and the searcher and the vast universe as the obviously perpetual hiding spot. It is one of those fields where scientists are cutting-edge Sherlocks, tuned into radio waves and scouring for that unobtrusive high from another universe. We are not following after some admirable people. This round of cosmic sneaking around began conclusively during the 1960s. Frank Drake, a man who could make even Einstein say, "Well, that's a keen treat," pointed a radio telescope at two sun-like stars and two tuned in. In spite of the way that he was invited with the sound of silence, Drake's condition, a logarithmic recipe to measure the amount of human advancements in our universe, set up for a long time to come. Fast forward to now, and SETI has abandoned a yard science project into an interstellar endeavor. Specialists use an assortment of devices, from the monster Arecibo telescope to the Allen telescope array, a collection of dishes that looks like a cutting-edge crop circle. The point is to get that one specific sign, a blip or a mumble, that makes legitimate contact from a different universe. These are radio transmissions that SETI consistently pursues after the benevolent you could hear on your FM dial, just with a touch more stardust. Yet in 1977, a sign named "Wow" was gotten. It was a radio burst so specific that it made the cosmologist who felt that it shout "wow" in the edges of the data printout. Was it ET calling home? Not exactly clear. Anyway, it filled the energy to keep the ears of our beast dishes open. At any rate, basically listening isn't enough anymore. With progressions in technology, SETI now looks for Technomarkers, signs of development, the sort that would show a human advancement sufficiently advanced to produce them. Picture this. An exoplanet washed in the radiance of city lights or canvassed in sunlight-based chargers. It's new to shimmer under a pariah sun. SETI's New Age venture is to detect these fake lights or current pollutions in untouchable conditions. An untouchable world, the same as tracking down deserts and coverings deserted in a huge park. These tries tie incompletely with the James Webb Space Telescope's mission. The JWST, with its sharp infrared vision, could be the boundless investigator that helps SETI with detecting these technomarks. It's a tag-team group of sorts where the telescope sees the planets and SETI tunes in for the signs of intelligence. SETI, albeit forceful, faces its fair share of hardships. Space is amazingly enormous, and signs can be as tricky as tracking down a needle in an intergalactic haystack. There's also the countless speed limit signals from human advancements. Countless light years away would take eons to reach us. However, regardless of the possibilities, the hunt continues, empowered by the likelihood of one day sorting out that in the grand cosmic show, we are, by all accounts, not the only players. The new discovery using the JWST might just be the best find in this hide-and-seek game. This pivotal revelation could propose that Proxima B has fake lights on its clouded side. At any rate, what does that really mean? Does it gather that an improvement sufficiently sagacious to use instruments like our own exists? Have we tracked down associates? Are we truly alone in the universe? The general idea of this divulgence is frightening, as there is a considerable amount more to progress. But more altogether, the endless number of possible results is the truly alarming part. We ought to dive into the nuances and see exactly what this suggests.